In arithmetic, you learn how to add integers, fractions, real numbers, and complex numbers. This trend continues because you can also add polynomials. To start, let's add the polynomials 2x squared plus 3x plus 4 and x squared plus 8x plus 1. I'll put parentheses around the two polynomials so it's clear that this is the first polynomial and this is the second polynomial. The main strategy when adding polynomials is to combine like terms. We'll show you several ways, and you can choose which method you prefer. There are 6 terms, 3 in the first polynomial and 3 in the second. Let's first group the like terms together. 2x squared and x squared are like terms because they have the same variable x with the same exponent 2. 3x and 8x are like terms. The exponents of x are 1. And finally, 4 and 1 are like terms because they're both just numbers. Next, we combine the like terms. For this, simply add the coefficients, the numbers in front. This gives us 3x squared, 11x, and 5. So adding these two polynomials gives us 3x squared plus 11x plus 5. Let's see another example. This time, we'll keep track of our work in a different way. Let's add 4x cubed plus 2x minus 1 and 5x squared plus 6x plus 3. Once again, we want to combine like terms. This time, we'll write one polynomial above the other and line up like terms. Let's write the first polynomial. 4x cubed. There's no x squared term, so we'll leave a gap. Then plus 2x and minus 1. On the next row, we write the next polynomial. 5x squared goes underneath the gap because there's no like term in the top polynomial. The 6x goes below the 2x, and the plus 3 goes below the minus 1. Now, like before, we combine like terms. There's only one term of degree 3, so the first term in the sum is 4x cubed. There's only one term of degree 2, so the next term in the sum is plus 5x squared. Next, we combine 2x and 6x, which gives us plus 8x. And finally, we add the two numbers, -1 and 3, which gives us 2. So the sum of the two polynomials is 4x cubed plus 5x squared plus 8x plus 2. Let's add some more polynomials. This time, the terms will be a bit more jumbled. We'll add -2 plus 8y cubed plus 2y plus y squared and 6y minus 3y cubed plus 11. We'll add these by grouping like terms. To make sure we don't miss anything, we'll cross out the terms as we group them. We'll group the terms from the largest exponents down to the smallest. 8y cubed and -3y cubed are like terms, so let's group them and cross them out. Y squared doesn't have a like term in the second polynomial, so we just write it down on its own and cross it out. 2y and 6y are like terms, so we group those and cross them out. And finally, we group the numbers -2 and 11 and cross them out. There are no terms left over, so all that remains is to combine the like terms. 8y cubed minus 3y cubed is 5y cubed. We then have y squared. We can't combine it with anything, but it's still part of the answer. 2y plus 6y is 8y. And lastly, -2 plus 11 is 9. So the sum of these two polynomials is 5y cubed plus y squared plus 8y plus 9. Let's see a different type of example. -4x minus 7 plus -2x minus 3. Don't let all the negative numbers distract you. The process is the same. Combine like terms. First we group negative 4x and negative 2x. Then we group negative 7 and negative 3. Combining the terms negative 4x and negative 2x gives us negative 6x. And negative 7 minus 3 is negative 10. So the sum of these two polynomials is negative 6x minus 10. Just because we're adding polynomials doesn't mean the coefficients need to be positive. You can add negative numbers just like you can add positive numbers. For our last example, we'll add three polynomials: x squared plus 1, 3x minus 4, and negative 2x squared minus x plus 6. Let's group the x squared terms, the x terms, and the numbers. Remember, the numbers are also called constant terms. X squared minus 2x squared is negative x squared. 3x minus x is 2x. And 1 minus 4 plus 6 is 3. So after combining like terms, we get the sum of these three polynomials: negative x squared plus 2x plus 3.